All right, so today what we're going to do is we're going to look at the sum of the interior and exterior angles of all polygons. And some of these you know, but there's also a pattern that we're going to talk about with all of this. So let's start with the sum of the interior angles. Okay, so the sum of the interior angles of any polygon. Now, we've already talked about a triangle and how many degrees are in every triangle, right? How many is that? 180 degrees. So we've proven every triangle has 180 degrees. So we're going to use the idea that since we know triangles, we're going to divide other polygons into triangles. So what I've done here is I've drawn several shapes that I've divided into triangles by drawing diagonals just from one vertex. Okay, now look at what happened here. When I drew this diagonal, I created two triangles, right? 1, 2, two triangles, but the angles of those triangles end up all being in the angles of the overall polygon, right? Like I don't have a triangle, I didn't create some crazy triangle in the middle where those three angles don't end up being part of the overall polygon. All right, so let's look at if we have a quadrilateral, we end up with two triangles, right? So each triangle has to have how many degrees? 180, so that means we have a total of 360 degrees. So 180 plus 180 gives me 360. So let's look at our pentagon. How many triangles do we end up having? 3 triangles here, right? 1, 2, 3 triangles. So that means we need 3 times 180, which is 540. Good, 540 degrees. How about my hexagon? How many triangles did I have? I have 4 triangles. Each triangle has 180 degrees. So 4 times 180 is what? 720 degrees. All right, I think I have 1, 2, 3, 4, 5, 6, 7. A heptagon here, I have 7 sides. So I have how many triangles? 5 triangles, so that's 5 times 180, which gives me 900 degrees. Okay, so I don't want to have to draw this out every time or memorize those necessarily. I mean, some of them are probably good to know and you'll start to memorize them. But is there a pattern here to how this works? Anybody see a pattern? What do you think? That's what we do.
How many?
You lost it? Okay, that's okay. Sophie? Say that one more time. Okay, so every time we add a side, we're adding 180 degrees, right? Okay, so that 180 is going to be important because we see that, or we did see it, over and over and over again, right? What about the number in front of the parentheses? Where'd that number come from? Yes.
It's the number of sides.
Okay, so the number of sides minus 2, and then whatever that is, we take times 180, right? That's actually our formula. So this is the formula for the sum of all the interior angles of any polygon. N represents the number of sides. Now, I don't know why, but a lot of times books will write it like this, even though it feels wrong algebraically because you usually put that number out in front of the parentheses, right, that you're going to distribute. So I don't know why, but a lot of times people write it as n minus 2 times 180. So n represents the number of sides. That's our formula that goes right here. N represents the number of sides, so take that. That gives us a number of triangles. Take it then times 180. Does that make sense? All right. Can I change this? All right, so it says find the sum of the angles of an nonagon. Sorry, I can't read all of a sudden. Find the sum of the angles of a nonagon. So how many sides does a nonagon have? That's 9, right? So I would have 9 minus 2. I need to multiply that times 180. So we need 180 times 7. What do you get? 1260. Good. So there's 1,260 degrees. That's a total of all the angles. So sum of all my interior angles. Is that okay? All right, the next one says find the measure of a single angle of a regular regular octagon. So this time we want a single angle, and it's a regular octagon. What does it mean to be regular? All the sides are congruent, all the angles are congruent, right? So let's figure out what's the sum of all of our angles for the octagon. So let's take 8 minus 2, multiply it by 180. What do you get? 1080, good, so 1080. Now, because it's a regular octagon, I can divide that equally by 8. What do I get? 135? You get 135 degrees. Now, if this wasn't a regular octagon, I wouldn't be able to do that, right? It would still add up, the total would still be 1,080 degrees, but I wouldn't be able to divide by 8 because they wouldn't necessarily all be the same. Is that okay? All right. So now let's talk about the exterior angles. So we talked about exterior angles with triangles, right? We just talked about extending the side and how the remote angles add up to be the sum of the remote angles is equal to the exterior angle. Well, there's also a pattern that deals with all the exterior angles. Okay, so for any polygon, the sum of the measures of the set of the exterior angles is, that's what we're going to figure out. So what I want you to think about here, I have a pentagon, but this can really be any polygon. So notice I've extended each side, right? So every pentagon would have 5 vertices, right? So every n-gon would have n vertices, right? If it's a 32-gon, it's going to have 32 vertices. Okay, so at every vertex, there's a linear pair, right? If I extend that side to make that linear pair, I'm going to have n linear pairs for any n-gon. All right, so let's think about that linear pair. I have 180 times n. That's my linear pair. But what I'm really interested in is just my exterior angles, right? I want to know just the sum of my exterior angles. So I need to be able to take away my interior angles. Does that make sense? Okay, so what's the formula for my interior angles? We just learned it. 180 times n minus 2. So if I take my linear pairs, take away the interior angles, I should just be left with my exterior angles. All right, so let's do some math here. We have 180n minus, I need to distribute 180n plus 360. Well, what happens right here? There's 0, right? Good, that's awesome. Okay, so that means it doesn't matter how many sides you have, how many angles you have. The sum of the exterior angles is always going to be 360 degrees. The sum of the exterior angles is always 360 degrees. I don't care if there's 3 sides, if there's 3,000 sides. It's always 360 degrees. Did you know that? No? Exciting new stuff today on a Monday. All right, so let's do 2 practice problems here. It says find the sum of the exterior angles of a hexagon. You should be done, right? What is it? 360. Good. All right, so now find the measure of one exterior angle of a regular octagon. So one exterior angle of a regular octagon. So let's think about that. What should the total be? 360, right? I have to divide it by 8 sides, or 8 angles, right? So what does that give you? 45 degrees. Okay, so now this is my exterior angle, right? I know we just did this problem, but I want to make a connection for you. What if I wanted to know the measure of one interior angle of a regular octagon? Keep in mind, we just talked about how an interior and an exterior together make a linear pair, right? So instead of using that formula again, I could just say, well, this is my exterior, then my interior has to be 180 minus the 45. So that has to be 135 degrees for my interior. Does that make sense? So not that the math is overly difficult, right? I mean, it's n minus 2 times 180. But it can save you a step, and sometimes it is faster to find your exterior angle first and work backwards to get the interior. Is that okay? All right, so I put an activity for you on Google Classroom. I'll pull it up real quick. So this is what it looks like. I did say that you might want to put your view at 50%, because I think then you should still, my screen's a little wonky compared to your screen. Okay, so I tried to build it to your screen, but I think you should still be able to read the questions. If you put in the right answer, part of the picture over here is going to be revealed. All right, so there's some like just 2 drop-down menus, some here in the table, and then some here calculating missing angles. All right, so this is your homework. When you're done, just hit turn in. But again, if you don't see a part of the picture revealed, then you probably went wrong somewhere. Good? All right, go to it.